Let's have a look at question 1b in this video. So we have data on the relationship between two variables, department and experience, on the logarithm of salary. Now we have here the descriptive statistics, so the mean and the standard deviations. Over here we have the variations, the sum of squares. Now we have the results for the two-way ANOVA, since we have two factors, two independent variables, department and experience. First, we have to use the rule of thumb to check if the equal variances assumption is reasonable, then give the test distribution, the degrees of freedom, compute the test, give the conclusion. So let's do it one by one. Let's start with the assumption. So to have a viable ANOVA test, to have valid results, we must have equal variances within the groups. And a rule of thumb to calculate that is that the largest standard deviation must be smallest than 2 times the smallest standard deviation. So let's see if that holds true. We have a look here at all the standard deviations available, and we can see that the largest one would be 0.2. So we write that down. Let's make some space here and write that down. So the largest standard deviation would be 0.2 over here. And then let's look at the smallest standard deviation. If we scan them, then the smallest one seems to be 0.101. So 0.101 times 2. If we calculate this, that's 0.202 versus 0.2. We can clearly see that indeed this relationship holds. So this relationship holds. The standard deviation of the smaller standard deviation is times 2 is greater than the largest standard deviation, meaning that ANOVA can be used. So that's good. We can keep going now. What do we have to do next? We have to give the test distribution for the interaction effect. So we look at the table with the ANOVA. Let me zoom in back to have a better picture, and we're gonna give the answers here. We're looking at the interaction effect. So we have the partial effects of the department, the experience, but then we need department and experience taken together. That's gonna be our interaction effect. We have the variation over here between the groups, and now we're looking for the degrees of freedom, we're looking for the average variation, the mean sum of squares, and then we're gonna compute the test. Okay, so we're gonna have an F distribution. That's what we're looking for, F distribution, since we're working with variations here. Now what's gonna be the degrees of freedom between the groups? The degrees of freedom between the groups is gonna be the number of groups of the first variable times the number of groups of the second variable, both of them minus 1. So we have how many groups? We have in the department, we have research product software, 3 groups over here. So we got 3 groups in the department. In the experience we have low, medium, high. So 3 groups in experience as well, meaning that the degrees of freedom for the variation between the groups is gonna be 3 minus 1 times 3 minus 1. 3 minus 1 times 3 minus 1, that's 2 times 2, which is equal to 4. So over here we would have 4. Now with the same logic, let's have a look at the variation within groups, and the variation within groups belongs to this cell over here, the error variation. So what do we have? We have 2.033, and then the degrees of freedom. The degrees of freedom belonging to the variation within groups, let's write them here to have them a bit more organized. The degrees of the freedom between the groups we found out to be 4. The degrees of freedom within groups must be the number of observation minus the product of the number of groups. So how many observations do we have in total? We look at the descriptive statistics to find that. Anything that describes our data, we look in this table. So the number of observations we're interested in here. We're interested in the total. So something in intersection with this. We can have a look here that the total number of observations is 104. So we're going to use that value, 104. Let's calculate it here below. So 104 minus how many groups? We have 3 for department, 3 for the other for the experience level. So 104 minus 9, that's going to be 95. So we got 95 degrees of freedom over here for the within variation. Now we go to the next cell where we have the mean sum of squares. So what is the mean? It is the average, and the average means that we're dividing the regular sum of squares that we found by the degrees of freedom. So it's just computation. 0.039 divided by 4 is gonna equal to 0.00975, and 2.033 divided by 95 is gonna give us 0.0214. So we got the mean sum of square differences. Now we can compute our f-test, because our f-test, let's do it in the last part of the question. The f-test is the ratio of the variation, average variation between the group, average variation within the group, which happens to be 0.00975 divided by 0.0214, and that's equal to 0.46. And intuitively we can see that the f value is quite low, meaning that the variation between the groups is almost the same as the variation within the groups. So we shouldn't have a reason to think that the variation between groups is significantly higher, so that the means differ. But let's just check it for sure. We look at the significance of this result and we can see it's 0.769. So this most likely happened by chance, meaning that it's completely insignificant. 0.769 is much greater than the significance level of 5% alpha, which means that we do not reject the null hypothesis, meaning we have no significant or insignificant interaction effect. Actually, we just do not have an interaction effect. So no interaction effect. There's no evidence for it. No interaction effect between department and experience. Hope this makes sense, and we are done.